This is section 5.3, part B, conditional probability and independence. Suppose you toss a fair coin twice. Define event A as the first toss is a head, and event B is the second toss is a head. We have already established that the probability of event A is 1/2, and that the probability of B is also 1/2. What's the probability of event B given that event A has already happened? Now, the event that A has already happened is just the probability you toss the first coin and you get a head. Since a coin does not have a memory, the probability that you flip the coin a second time and get a head has nothing to do with the event of the first toss. The coin has no memory. So the probability of getting a head, given that the first toss was already a head, is still 1/2. In this case, the probability of event B is equal to the probability of event B given event A. Because we know that the first toss of getting a head does not affect the probability of the second toss also being a head. Two events A and B are independent if the occurrence of one event has no effect on the chance of the other event will happen. In other words, events A and B are independent if the probability of event A given event B is equal to the probability of event A, and if the probability of event B given A is still equal to the probability of event B. Let's return to that pierced ears example. We're going to define event A as that the student is male, and we're going to define event B as that the student has pierced ears. We have already established that the probability of event A is 90 out of 178, and the probability of event B is 103 over 178. What's the probability of event B given event A? Now, to do this, the probability of event B given A tells us we already know that the student is male. So we're going to look at the total number of male students, in this case, which is 90. And given that they're male, how many of them have pierced ears? And we know the total number of men who have pierced ears is 19. So the probability of event B given A is 19 out of 90. The event of P given A and the probability of event B are not the same fraction. Even if we were to reduce these fractions, if it were possible, they would still not be the same. So since the probability of B given A does not equal the probability of event B, then we know that events A and B are not independent of each other. They are dependent. So is there a relationship between gender and handedness? To find out, we use a Census at Schools random data selector to choose a simple random sample of 50 Australian high school students who completed a survey. The two-way table displays data on gender and dominant hand of each student. Are the events of male and left-handedness independent? Justify your answer. So to do this, let's define event A, that the student is male, and event B, that the student is left-handed. Now from this table, we can see that the probability that the student is male is 46%, because 23 out of the total 50 students were male. The probability that the student is left-handed, there are 7 out of the 50 students who are left-handed, so it's 14%. The probability the student is left-handed given that they are male, so of the 23 male students, we know 3 of them are left-handed, so 3 out of 23, or 13%. And the probability that they are male given that they are left-handed, so out of the 7 students that are left-handed, we know 3 of them are male, so 3 out of 7, which is 0.43. Since neither the probability of A is equal to the probability of A given B, or the probability of B is not equal to the probability of B given A, We know that these two events are not independent. So for each chance process below, determine whether the events are independent. Justify your answer. Shuffle a deck of cards and then turn over the top card. Put the card back in the deck and shuffle again and turn over the top card. Event A is the first card as a heart. Event B is the second card as a heart. Since we're dealing the first card, then putting it back in and shuffling, we are not changing the probability of the second event, and what you dealt for the first card has nothing to do with what you're dealing with for the second card. Then these two events are independent. Shuffle a standard deck of cards and turn over the top two cards one at a time. Define event A is the first card as a heart, and B is the second card as a heart. These would be dependent events because once you flip over the first card, whether or not it is a heart will change the probability that the next card can be a heart. So we have the first card, there's a 13 out of 52% chance that we would get a heart. Now, if that card was a heart, the chances that the next one would be a heart would only be 12 out of 51. Or if the first card wasn't a heart, the chances the second one would be a heart would be 13 out of 51. But whether or not that first card is a heart will determine the probability that the next one is. So these would be dependent events. The 28 students in Mr. Tabor's AP Statistics class completed a brief survey. One of the questions asked whether each student was right-handed or left-handed. The two-way table summarizes the class data. Choose a student from the class at random. The events of interest are female and right-handed. So we need to see if these events are independent or dependent. So we're going to define event A as that the student is female, and event B is the student is right-handed. The probability that the student is female, out of all of the students, all the 28 students, we have a total of 21 of them are female, so there's a 75% chance of selecting a female. The probability the student is right-handed, there are 24 students that are right-handed out of all 28 students, which is about an 86% chance of selecting a student who is right-handed. Now, if we look at this chance that a student is right-handed, given that they are female, so of the 21 female students, 18 of them are right-handed, which again is about 86%, which does exactly equal the probability of event B. And the probability that a student is female, given that they are right-handed, so out of the 24 students who are right-handed, 18 of them are female, which is 75%, which also equals the probability of event A. Since the probability of B given A is equal to the probability of B, and the probability of A given B is equal to the probability of A, we know that these events are independent.